Hey guys, so this is going to be a video on finding missing side lengths of similar triangles using ratios. As you can see, I have two examples here. I'm going to work through each of them. Alright, so here's the first one, and I'm actually using the length of the squares to represent the unit. So here we have 8 squares. That's how I get this 8, and here I have 4 squared, so that's how I have 4 and 4, and of course this adds has to be 2. Alright, so let's solve this using the math that we learned in class to make this x actually be 2. Alright, so the first thing that I'm going to do is create a ratio. Okay, so I'm going to use the given numbers to create a ratio. So here, these two numbers work perfectly to give me one ratio. By ratio I mean fraction, which is 4/8. Now, at the beginning, my first fraction, my first ratio, it doesn't matter in which order I place it. This could have been 4/8, it could have been 8/4. It doesn't matter. Now, the second fraction is going to matter. Okay, my second fraction will consist of, well, x to be on top over 4 to be on the bottom. You can see the relationship, how it works. On the bottom, on top, and on top. Then you're going to do cross multiplication. So you're going to do 8 times x, giving you 8x equals 4 times 4, giving you 16. Also, this order doesn't matter. You could have done 4 times 4 first to get 16 on one side and 8x on the other side. It'll be the same thing. In the end, you will have to divide both sides by 8. 8 cancel out, leaving you with x equals, well, 16 divided by 8, that is 2. Perfect, we got the right answer. X equals 2. Now, this is one method where you created the ratio using one triangle. There's another method you can use, which it's the same thing. In that method, let me actually do it. I can do 8/4. Okay, so this is going to be the same problem, just using a different method. I'm going to create a ratio now using corresponding sides. 8 corresponds to 4, so I can have 8/4. Okay, again, the first one doesn't matter. I could have said 4/8. The first ratio doesn't matter. I am placing corresponding values together to create a ratio. Then also 4 and x are corresponding values. But notice the length of the big triangle was first on top, so the length of 4 will be first as well. 4/x. Okay, so this one was on top, this one was on top. These two are corresponding, so this goes on the bottom, and this goes on the bottom. Okay, you can use whichever method you want. They both will be the same thing. Notice 8 times x gives you 8x, and 4 times 4, 16, and we get the exact same thing when we simplify for x. X equals 2. Okay, so two different methods. Use whichever you like best. Now, some of you might actually see a problem like this one, number 2, where you have a lot more values and things might be a little more complicated. Well, one thing that you can do in case you see these type of problems is that you can separate the triangles. Okay, so let me do that. I have this triangle. The little one, it's something like this. That's the little triangle. And the big triangle is something like this. Okay, so I just drew the two triangles apart from each other. The length of this is 4. The length of this whole top, as you can see, it's going to be 4 plus 4. That's going to be 8. the length of this is 6, and the length of the big one is x. Now, if you want to, you can separate the triangles. There's some people, or there's some students that are able to do this without separating them. Just for the sake of making it easy, I'm going to separate them. And here's how it goes. Well, I'm going to do pretty much the same thing that I did in these two. I'm going to create a ratio using 4 and 6. So 4 on top, 6 on the bottom. And again, the first fraction doesn't matter the order. Now the second one is going to be 8 over x. Okay, so this one was on top, therefore this one also has to be on top. This one was on the bottom, therefore this one also has to be on the bottom. Then I can do cross multiply. 4 times x gives me 4x equals 6 times 8, that's 48. And then when I divide both sides by 4, I get x equals 12. And there we go. So that means this value, x, is 12. Alright, this is 12. So there is the process. And again, you can also use this method for corresponding sides. I'm not gonna do that. I think that's good enough. But this is pretty much the general way of finding missing side length using either corresponding sides and setting up ratios. Okay. Now also notice that these are right triangles, so I could have used the Pythagorean theorem, but this is not a problem where that is required. Okay. That's it.